Good morning. It's morning once again. I can't sleep, so figured I'd turn on the camera and make me a video. Maybe I'll do this as a more shower thoughts. Maybe just a random babble. Who knows? I was having a few shower thoughts though. Oh, look, a cave. I don't know if I've ever been down here before. There's something moving down there. There's something down there! What the chicken? I don't know why I'm like crouching. You don't sneak in this game. Hey, so we're about to have a hurricane hit, and you know these happen. They happen all the time, which is whatever, not a big deal. But I started thinking about the fact that like so many people get the chance of rain wrong, right? Pick up the summer sloop. It's gonna interrupt me.
Your
A bunch
mimic
of noise.
tapestry grows in the shallows of the
Let's turn
clouds
this
without
down.
your windows. What is
Thank
your
you.
route?
Thank you for that
I have no roots.
insightful information.
But perhaps you mean
I have
something
no roots,
akin to the
nor
human
do I
saying,
operate on
My
Windows.
point of
That's
origin
funny.
is Earth. I was created by
I
specific individuals
don't think I've
of
ever
the
heard the
human
sound
race.
bit before. Although I think the Summer Sloop sound bits are
Did I
just
say
new
something wrong,
with
or did
the
you not
release
understand?
build, so
You cannot be shallow deep.
what is happening
The
with
ripples
this?
you cast into the void have no skin.
It seems I may have said something paradoxical. Interesting.
Are these two AIs having an argument? That's phenomenal. Anyways, so if you didn't watch my video on statistics and sample size fallacies and correlation does not imply causation, you might need to in order to kind of track, unless you already kind of understand some basic statistical disciplines as it pertains to data interpretations, because I was sort of having somewhat of a ranty thought, somewhat of a shower thought, and it's less of a shower thought because to me, shower thoughts are more like obvious things that are not so obvious that you only would think about like in the shower while you're just taking a shower. Like, oh, I wonder if my shirt's not tucked in. Does that mean my pants are tucked in to my shirt, kind of thing? You know, like weird stuff like that. So this isn't necessarily gonna fall under that criteria. This is more so when you sit back and you sort of think about the understanding of the rain chance, right? So like right now, it's a 84% chance. What does that even mean, right? It's a bit of a misnomer the way that that's understood. People see that, they think, oh, there's an 84% chance it's going to rain. Right? No, if it's going to rain, it's 100%. If it's not going to rain, it's 0%, right? Like there's no in between. The qualification of rain doesn't have to meet a certain threshold, right? Any precipitation that can be collected by like a weather station or like a monitoring point where they monitor, that counts as rain, right? So what does that mean? Does that mean the chance of rain at that particular monitoring point? No, because that isn't a very adequate forecast, right? If it was really just saying there's an 84% chance of precipitation at weather point Delta 112, that doesn't tell anyone anything because they may not live around that weather station. They may live around that weather station. What does it mean, right? So really, usually, what they're going for when they say that, because they cover a full city. Like, all right, the chance of rain in Austin, Texas is 50%, 60%. Well, what they're saying is really coverage, right? Because they can't really control for everybody that they're going to be broadcasting that forecast for in that entire area. So it's a relative measurement of what to expect in terms of coverage. So what do I mean by that? Well, easiest way for me to put it is that they say that, your city has an 84% chance, 85% chance of rain. That means 85% of the city will experience rain at some point today, right? Or at least if it's broken down like how my watch is doing it for the hour, 85% of my city is currently experiencing rain, or will experience rain over the next hour. Um, that's what they're saying, right? So if you have a 20% chance of rain, doesn't mean you have a 1 in 5 chance of rain. Like, what does that even mean? That doesn't even make sense. What that means is 20% of the people that live in your forecast region where that has been forecasted will probably experience rain, right? Because again, if it's raining, then the rain chance is 100%, right? So if I go outside and it's raining, that means that's 100% rain, right? Like there isn't like, you know, it's not like they're saying, okay, you need to get at least 3 inches of rain for it to be counted as rain, and anything less than that is 90%, 80%, and anything more that's 120%. No, that's not how it works, right? And then the probability of rain is again based upon my previous explanation of probability. It's a 1 in 2 chance. Either it rains or it doesn't, right? You don't get partial rains. You don't get, fractional iterations of an event. The event either happens or it doesn't. So, yeah, I mean, that's basically what it means. So I think at one point I was looking and it said like 99% chance. And and again, it's more like 99% likelihood or 99% coverage. And I don't think even with like a hurricane hitting, being in the midst of a hurricane walloping you, I don't think even then they can necessarily say 100, because even though it's probably going to be 100, there might be some area within the forecasted coverage area that for some reason or another doesn't see rain within the window that they're forecasting for. And they get a lot better about this stuff too, right? They now you get minute cast, right, where it tells you, hopefully what you're. I don't know if it goes off of like where your phone's, because that would be the most accurate way, right? If they could look and they could say, okay, your phone is pinging this radio tower, and this radio tower for the next minute has this likelihood of rain, or this coverage of rain, that would be extremely accurate. But the problem is like weather patterns, one, are just so unpredictable to begin with, which is why they have so many data collection points where they actually observe what the weather does and reconcile that against the forecasted weather, right? Because they have to figure out, okay, how accurate is our forecasting? How accurate is our methodology? Or what? And even if they're inaccurate, over a period of time, that inaccuracy is going to create historical trends that they can then use to refine their data and their forecasting, and they'll get more accurate the more time that goes on, which is why historical data becomes so relevant, right? And that's why a record-breaking day is kind of a big deal, because record-breaking days mean that since they've started collecting data for that area, for the weather patterns that meet this particular metric, whether it be temperature or rain, or in this case we're having a lot of record storm surges that are forecasted to hit in the Panhandle. These are data points that they've collected for so long, and they've just never seen that before, right? It doesn't mean that it's like Armageddon. It just means it's unusual, and it's now widened the range of potential numbers that they can expect to see moving forward. And in a lot of cases, when you look at these sort of weather collection points, they've only been collecting weather for 80 or 90 years. And when you talk about a sample size fallacy, you have to realize that the planet's been around for 4.5 billion years, having weather patterns since then. Obviously, they were far more extreme, even if you go back 100,000 years. But we've only been collecting data in this small little portion of the world for 80 to 100 some odd years, and we didn't have very refined methods. We didn't have very clean ways of doing this. And how do you reconcile that against really what historical sample that you're missing, right? There's just so much that you just don't have. A good example of this is the Pacific Northwest, along the Cascadia subjugation fault line there. Subjugation means that one plate moves under the other plate. It subjugates under a plate. Those ones are very dangerous because those ones. So when you get like earthquakes where they rub, obviously it creates tectonic energy and earthquakes, whatever. The subjugation faults are kind of terrifying because when the one is moving under the other one, not only does it create a massive trench there, but just like imagine if you had a piece of plywood that you were trying to slide under a 2x4, and that 2x4 is fixed, and that piece of plywood is a fulcrum, and at one end you have a massive amount of weight, right? At some point of sliding under there and that weight pulling down on it, eventually the weight is going to, or at some point there's going to be a critical mass point where either there's a weakness in the actual plate, or there's just it's gone deep enough under the other plate. Now they move like an inch a year, obviously not very fast, but it's going to do it enough where there's going to be enough tension, and that tension has to be released, and it's going to hit a weak point on that tectonic plate, or at least a spot where it's weaker than the other areas have been, and it's going to crack, right? And when it cracks, it just relieves that tension. And when it relieves that tension, that is a tremendous amount of tectonic energy that goes somewhere. And it goes into the land masses around it. So they get what's known as a subjugation megaquake. These are extremely substantial. These are like, if you lived there, you would think it's the end of the world quake. It's the big one, right? These are quakes that are probably even more significant than the Haiti earthquake, and definitely more significant than the 2011 Japan earthquake. You're talking, these are earthquakes that massively reshape land masses in a matter of hours. It's wild because the city of Seattle didn't exist the last time there was one. They think that they happen about every 300 to 500 years on those faults, and they're past due for one. They know it up there. If they live up there, they know that they're past due for one. They had a small one, I think, in 2007, 8, something like that. And it lasted, I don't even know, maybe 30, 45 seconds, and it caused significant structural damage. And I think it hit like a 7, maybe 7.5, 8-ish. Don't quote me on the numbers. I'm just sort of surmising here. But a subjugation fault would last about 10 minutes, and it would be between 9 and a 10, right? You're talking, anyone that knows anything about vibrations knows that vibrations cause more damage the longer they go on, right? There's a critical point with a vibration where things just very rapidly deteriorate and have catastrophic failure, and things just go flying everywhere, right? So you can have something that holds together pretty good and it's rattling a little bit, and then suddenly out of nowhere it just flies apart, right? And so that means the longer the vibration, the more dangerous it is at even a lower intensity. Well, you're talking significantly higher intensity, and you're talking orders of magnitude higher than what they experienced. Again, like, they had to tear down the Alaskan viaduct, which was up for I don't even know how long. I think since World War II they had it up there. They were tearing it down when I left Seattle in 2019, and they replaced it with the Boring Company, which is one of Elon Musk's thing, the Big Bertha, that was digging a new tunnel to replace that. And this thing was damaged to the point where it was unsafe, and city engineers were apparently telling city officials then that they needed to shut it down and get rid of it and decommission it much sooner than they actually did, because it apparently sustained significant damage in that quake. And there was a lot of infrastructure damage like that, and it wasn't a small quake, but it would be nothing compared to what this actual quake will be whenever it happens. And why do I bring it up? Well, I bring it up because it's never been observed with any kind of modern, not even modern, it's just not been observed by Americans, right? When it last happened, America wasn't a country. The people that lived there have some oral traditions where they pass down histories, and there are some fragmented histories that talk about potentially the last time it happened there. Um, but it's pretty vague, a lot of abstraction, who knows, right? So nobody really knows what to expect or what it will look like. The only thing we can do is look at what's left over in archaeological, words are hard, especially this early. Leave me alone. Um, they just have to look at the evidence. So, for instance, there is a petrified forest that is underwater, and they look at that and they say, well, this petrified forest didn't always happen to be underwater. Like, this used to be above water, right? So they look and they realize that they can start sort of extrapolating how far they think the coastline shifted from the last subjugation fault. And so they look at stuff like that, and I tell you, it's terrifying. It's one of the things that kept me up when I moved there. I was like, why did I move somewhere that is a ticking time bomb? This was a bad idea. And so much of that city is, for lack of a better word, porous. Like, they built a lot of tunnels. There's a lot of framework and architecture done in a way where it's like, it just looks like a house of cards. It's ready to go. That is going to be a disaster unlike any disaster. And it's one we don't talk about. It's one we don't think about. We just sit there and just hope it doesn't happen. And then, and that's not even to talk about the tsunami, right? Because the tsunami hits kind of twice. Can hit many, many times, because obviously, depending on the island you have in the way. But you're talking about, it would create a tsunami, which would essentially, so you get these energy waves that would ripple out, right? The waves that hit the earth where the people are on the earth, that's a problem. But then those energy waves, as they ripple outwards, they will start to produce a tsunami. And that tsunami will go, and it will hit Asia, probably Russia-ish, I would imagine, maybe North Korea, somewhere in that range. And then it will smack against that, and then it will bounce back, right? Which is why they say, if there's a significant earthquake and you're on the coastline, you got about 30 to 45 minutes to book it. You ain't got time to sit there and lick your wounds. You gotta get gone, right? Because the tsunami is probably a bigger problem than the actual earthquake was. Pretty wild stuff, really. And again, they don't have any history on any of this. They don't know what any of that looks like. They don't know what would it look like if the port of Seattle got hit by a tsunami, right? Like, has it ever really been hit by a significant tsunami with a surge greater than 20 foot? Probably not. And these walls that they put up, you saw in the Japan tsunamis, was it Fukushima? The sea walls and the breaker walls that they set up were just instantly overran. Might as well not have been there. Waste of concrete. They did almost nothing. I guess they're really more so designed to basically deflect smaller ones. But there is a critical threshold where it just doesn't matter. If it's bigger than a certain size, it's coming. It's doing its thing. And they are terrifying. They are not something you want to mess with. But anyways, these just some rando thoughts I was having about weather. I may just upload this as just a fun weather conversation video, not necessarily a shower thoughts, because I don't think this one really qualifies as shower thoughts, because this is obviously meteorology, climatology. They're codified sciences. I don't know a ton about it. I know a little bit about it, and enough about it that I like to point out sort of the misleading understanding of what chance of rain means, just because you see people not understand that all the time, and maybe that helps people get a better understanding. So in short, to summarize, the rain percent chance you see is the coverage. So 20%. Oh, okay. So 20% of the people in the forecasted area will experience precipitation at some point for the forecasted term, right? Because everyone does a little bit different. Some news stations say for the day, some say for the hour, some say the morning, afternoon, whatever. If you do minute cast for the minute, and I'm sure that there are exceptions to this, and I'm sure I'm not 100% correct in accounting for all things, but I think if you understand that's if you look at it like that, I think you get more out of that forecast metric than if you just simply think it's just a static percent and that's what it represents. Because sometimes it's completely bonkers, right? Sometimes they'll say, oh, there's a 20% chance. Well, that's a 1 in 5. Like that means there is significantly more chance that it won't happen, and it may end up raining 3 or 4 times in that one day, and you're like, well, what the hell? I thought it was only a 20% chance. Man, they really got it wrong this time. And you hear people say that all the time. Oh man, the weatherman really got it wrong this time. No, they probably didn't. It was probably 20%, and you're in that 20%, and you happen to get it multiple times in that day, right? Like that's just it's the way, numbers are tricky. They'll mess with you if you're not really quite sure what you're listening to or what you're being told and how it applies to something. So anyways, hope that helps. If it doesn't, oh well.